Hello guys, let us solve one more standard function in this video, that is y equal to e power ax into sine of bx plus c. Here if we see in this standard function, we have combination of two functions, that is it is not the single function, so it is not easy to derive as like before. So we have to make use of one more formula, that is d by dx of uv is equal to uv into d by dx of v plus v into d by dx of u. With the help of this formula, by considering e power ax as u and sine of bx plus c as v, if we derive this, that is it will become as y1 is equal to u means e power ax into d by dx of v means d by dx of sine of bx plus c plus v means sine of bx plus c into d by dx of u means e power ax. Now we already know that derivation of sin x is cos x, that is e power ax into cos of bx plus c. But we know that this is not in the x1, so we have to derive again, that is d by dx of bx plus c. And then similarly, sin of bx plus c into derivation of e power x, that is e power x itself. But the thing is, it is not in the x1, so we have to derive again as like before. So finally, it can be written as e power ax into cos of bx plus c into, here derivation with respect to x becomes 1 and constant becomes 0. So finally, we will get as b, and in the second term, sin of bx plus c into e power ax into derivation of ax with respect to x, it will becomes 1. So we will get as a. And also we have common e power x, so we have to take it as common, that is e power ax into b cos of bx plus c plus a into sine of bx plus c. Now guys, if we see for y1 we are getting 2 terms, for y2 we will get 3 terms, and for y3 we will get 4 terms, like that it will increase so on. So we cannot derive the antiderivation with the help of that pattern. So to resolve this, we have one more technique, that is by replacing b and a values with r cos theta and r sin theta, that is a equal to r cos theta and b equal to r sin theta. And also I will explain how these values came. These values are came because of the right angle triangle. Suppose if you consider the right angle triangle having 90 degrees and this is theta, by considering this as adjacent side, that is a, and this as opposite side, that is b, and hypothesis side, that is r, we know that cos theta equal to adjacent side by hypotenuse side, that is a by r. From this we will get a equal to r cos theta. And also we know that sin theta equal to opposite side by hypotenuse side, that is b by r. So we will get as b equal to r sin theta. And also we know that hypotenuse square equal to side square plus side square, that is r square is equal to a square plus b square, that is r equal to root of a square plus b square. And also we have to derive the value for the theta. So for that we have to divide b value to the a value, that is b by a equal to r sin theta divided by r cos theta. It can be written as r can be cancelled, and sin theta by cos theta can be written as tan theta, that is b by a. So finally it can be written as theta equal to tan inverse of b by a. Why we are finding this r value and theta value? Because we have to substitute these two values in the last step, that is antiderivative step. Now let us replace a and b values as r cos theta and r sin theta, that is we will get as y1 is equal to e power ax into, in the place of b we have r sin theta into cos of bx plus c plus a value means r cos theta into sin of bx plus c. And if you see clearly, we have one more term common, that is r value. So take it as friend, that is r into e power ax into sin theta into cos of bx plus c plus cos theta into sin of bx plus c. And if you see clearly, it is in the form of sin a cos b plus cos a sin b, that is sin of a plus b. Sin of a plus b equal to sin a cos b plus cos A sin B. With the help of this formula, we can written it as r into e power ax into sin of, here A means theta, plus B means bx plus c. This is the final derivation for the y1 after replacing the a value and b value with r cos theta and r sin theta. Now similarly, if we do the derivation again, we will get y2 as r2 into e power ax into sin of 2 theta plus bx plus c. Similarly, y3 can be written as r cube into e power ax into sin of 3 theta plus bx plus c. Similarly, with the help of that pattern, we can derive the antiderivative, that is yn is equal to r power n into e power ax into sin of n theta plus bx plus c. Now here we have to substitute the values of r and theta, because in the question, that is y equal to e power ax into sin of bx plus c, we don't have values of r and theta. So we have to replace the r and theta values with the a and b values. So already we derived the values of r. So let us substitute those values as root of a square plus b square whole power n and e power ax into sin of, we know that value of theta is tan inverse of b by a plus bx plus c. It is the final antiderivative for the given standard function. Thanks for watching.